Okay, now we're going to start learning about the second half of Unit 10, which is about finding the area and perimeter. Now you know that in the past we've been given this formula sheet, and most of the things we've been asked to find the area of have been on the formula sheet, like triangles and rectangles and circles, trapezoids, parallelograms. Now though, we're going to start to find the area and the perimeter of composite figures. So a composite figure is simply a shape for which you don't have a formula that lets you easily determine the area. Composite figures require a little bit more work on your part. Keys to finding the area or perimeter of a composite figure are as follows. First, you have to divide it into the shapes for which you do have formulas. Rectangles, triangles, circles, trapezoids, semicircles, anything like that that you have a formula for. Next, you have to find any missing lengths by doing two things. First, you have to remember that the opposite sides of parallelograms are congruent. That includes rectangles and squares. It means they have the same measurement. And you have to remember the Pythagorean theorem, a squared plus b squared equals c squared. Finally, once you've figured out the area of the shapes that you need, okay, you'll have to add them or subtract them to find the area of the bigger shape. Or you'll simply have to add together all of the outside lengths of the bigger shape to find the perimeter. Okay, you might want to pause this now to make sure that you get this into your notes on page 117. Let's take this as an example, okay? We could actually treat this as a trapezoid, but let's not. Let's pull it apart as if it were a composite figure. We have two figures here. We have a rectangle and we have a triangle. Let's look at them separately. The formula for the area of a rectangle is simply length times width. So we're going to do 6 times 8 to get 48. The formula for a triangle is 1/2 base times height. In this case, the base is 6 and the height is 8. 6 times 8 is 48 times 1/2 is 24. If we want the area of the entire figure we started with, we add them together and we get 72 square inches. Remember, units are particularly important in this Unit 10. Let's try another shape now that's not quite as easy. You have to divide this into shapes we know. Well, it looks like two rectangles. So let's see. We have one rectangle right there. And because this side is 8 meters, we know that that side has to be 8 meters. So right away, we can figure out that 8 times 14, right? 8 times 14, that's our rectangle here. That's going to be 112. This one, though, we can't figure out yet. We know that this side is 20, but we don't know this side. How do we get it? Well, we have to do a little problem solving. We know that the whole thing is 24 meters, and we know that this side up into the red line is 14 meters. How much is left over? That would be 10 meters. So now we know that the rectangle on top is 20 times 10 is 200 square meters, and the one on the bottom is 8 times 14 is 112 square meters. That gives us a total for the entire composite figure of 312 square meters. Let's go back to the first one we saw, but make it a little bit more challenging. Now, it'll turn out to be the same, but we don't know that. So how can we do this? Well, we have to do it the same way we did the last one. If this is 6, then that one is 6. We know that the whole thing is 16, but the only thing we know on this side is 10. Well, we can use our friend the Pythagorean theorem. This side is C, this side is A, this side is B. C squared, 100, minus A squared, 36, gives us 64. Square root of 64 is 8. And that, since this is 16 inches, tells us that the bottom is 8 as well. So we can use that to figure out the area of the composite shape. And if we wanted to do the perimeter, we would simply go around the outside and do the perimeter. 8 plus 8 is 16, plus 6 is 22, plus another 8 is 30, plus 10 is 40 inches. Remember, perimeter will be in linear measurement, and area will be in square measurement.